Hey guys, Mr. Bowman here. Today's learning objective is in green and we are learning to write the domain and the range for given equations and graphs. So our starting point is what exactly is a range and a domain. So a domain are all the valid x values you can put into an equation. Values, apologies about that, can into a graph. And I suppose the opposite of the domain is the range, and that relates to the valid y values of a given graph. So to demonstrate these concepts, we're going to go through these 5 graphs that we've got pre-drawn for us, and we've also got their equations to support our answer. So for graph number 1, y equals x, we'll need to write down the domain and we'll need to write down the range of that graph. So the domain of this one, so again to recap, it's all x values that can go into the graph or the equation. And if you think about this graph, we're dealing with a big y equals x, that's a straight line. In theory, it goes on forever upwards and it goes on forever downwards. So that means all x values and all y values are valid for our equations. And the way we write that is our domain is an R, and we normally put that in brackets, and R relates to all real values. And you'll find a lot of the graphs we look at, the domain will be all real values. And the range, again, if we look up and down the y-axis, any value on there would have a corresponding point. So there's no limitation to that. So the range of that equation is also an R. So that's all real values. Let's have a look at the second question, question 2. So that relates to that blue parabola. We can see that its y-intercept is down there at -3. And we can see the x-intercepts are just before -2 and -1. So we've got that y-intercept there. Let's have a think about our equation. So this time around, we're going to write our equation down, which we normally should do. And next to that, we're going to write the domain. So in our case, we're thinking of the x-axis. If we go this way, we would expect there to be corresponding x values, and that would carry on. It's just those values would be really, really big. And again, if we go to the left, we would expect there to be values at any of those points. So our domain for x squared minus 3 would also be all real values. So let's get rid of those arrows. And the next thing we need to think about is the range. So if we're on the y-axis, let's start at 0, we can go up and up and up, and there will typically always be a corresponding value that relates to that. However, with this parabola, we can't go down, 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 because that stops at -3. There's no y values that is below that point. So our range in terms of y values, we need to express it as an inequality. It's anything equal to or greater than -3. And what that means is there is a value for anything above 3 or -3, and there is no corresponding part of the graph that sits below -3. Okay, so we've got that there. Let's get rid of these scribbles to help us with our next question. Okay, we'll use the green pen now. So we're now going to look at this cubic. The cubic is in green. It's got an x-intercept of -3, -1, and +4. And again, we need to start by writing the equation down. So x minus 4, x plus 1, x plus 3. let's explore the x-axis. If we go across, you would expect the values to be down there. If we go this way, you'd expect the values to be there. And if we went further, you'd expect the values to be really big up in this direction. So it looks like the x-axis in that direction appears fine. If we explore the other direction, we can see the graph. We can see the graph above us here. We can see it there. And if we went this way, we would expect it to be really low, a small or big negative number. So in that case, it looks like all real values or all values of x would be valid for this cubic. So our domain would be all real values of x. Now let's flip around. Let's think about the y-axis. If we go down, we would expect answers. And what happens is the line on this side, this would actually perpetually go down because it does go up and then down. And then this one here, we expect to come back up again here. But this one here will always go down. And that means any negative x value or y value should have a corresponding x value or should be represented on our graph. And the same when we go up. Whilst there's a peak up by 6 here, we do expect the other side of the graph to keep going up and up and up and up. And that means we would expect no y value. We would expect the y value to have every issue with that. So that means the range for that graph, again, all real values. So all x values and all y values will have a corresponding point on our graph. So let's get rid of all that mess. The next question we want to look at, we will use the orange marker now, is the hyperbole. We've just learned about hyperboles in the previous video, so that there's number 4. Let's write down our equation, 1 divided by x minus 3 minus 2. The hyperbole is in purple, and if we're starting on the x-axis, right on the origin, if we go towards the negatives, well, we would expect there always to be corresponding values on our graph. We would expect the graph to be valid there. And if we go to the right, or to the positive numbers, we would actually expect it to go forward. However, there will be one point in our graph, I'll put a dot there, at 3, where we know there will be an asymptote. There will be no mathematical value in that equation, and that's because we're dealing with 1 divided by 3 minus 3, which would be 1 divided by 0, which would be a math error. So at that point there, that graph would have no value at x, and if we pass that, our graph reappears and we would expect it at every other point. So that means for our domain, that would be all real values except x cannot equal 3. So that's slightly new. So it's all real values except for that one exception of the asymptote. We'll get rid of all that working, and we're now going to look at, so that was the horizontal asymptote. The range relates to the y values, and we're actually going to expect another asymptote. And so again, let's start at 0, 0. If we go up this way, up into the positive numbers, we would always expect a corresponding point on our graphs. So in terms of our range, all positive numbers will be included. And if we go in the other direction, we'll go down. Initially, there will always be a corresponding value. But however, when we get to that -2 number, there would be no answer for that. So again, there's an asymptote. There's no mathematical solution at that point. And then once we go past that, again, we get back to there being a graph that represents that portion of the line. So our range would be all real values except y cannot equal -2. Okay, And our last graph's a bit weird. We've got that black graph. It appears to have an x-intercept at -5. And we can confirm that by looking at the equation where we've got a +5 there. Our first step, let's write down our equation. Y is equal to -x plus 5 squared. Let's start off with our domain. So our domain, let's go left here, also to the right, and we actually stop. Our graph mathematically stops, and we've probably artificially done this. And that appears to stop at -3. And if we go in the other direction, that appears to stop at -7. So that means our domain, or our x values, they are only valued for values that are between and equal to, or that are including -7 and -3. So any value beyond -3, there is no corresponding point to our graph. And on the other side of it, any values less than -7, there are no values that represent that graph. Okay, so we've done that one. Let's have a look at the y-axis. So we're starting up here. There are no values above the y-axis. And there are no values that are below -4. And that's to say our graph only sits between 0 and -4. There's nothing positive and there's nothing below -4. So that's a restriction on our graph, and that's a restriction on our range. So our range are y values that fall between -4 and include and 0.